Go silent.
Wait, that's literally life where you don't
I
like.
like that.
Wait,
K-pop even harness.
it's good.
It's actually good.
And the song Golden.
Okay, folks.
Do you want to sing for this last? I'd love to sing.
So, as you notice, it's a pretty short unit, so you won't have a lot of time with this partner, but it'll be quality time. So we have 5 days of review and then the exam. We do have one quiz, one test. I've been unable to put this on the hub yet because the freaking hub is down. My language.
And so I think Pearson's down.
And Pearson's down. What? It's all part of Amazon Workspace. There's a global outage.
I saw it on my internet.
Did you?
So it was like, it was like a bunch of things that were working.
You know who's making
Yeah.
Oh, the new
Yeah,
one.
so I think that's this Friday, isn't it? Yeah, this Friday we have a quiz. This Friday.
Transformation.
So today's day 1. Day 2 is next time, of course, and then our day 3. Remember, this day 3 is not day 3 of the cycle, day 3 is right unit. So we'll have our quiz then. The next couple of days, you will need your graphing calculator, so please make sure to bring it. You don't need it today. But if you brought it, thank you for being prepared. I do appreciate that.
I did pretty good.
Okay, so let's get right into it. You ready? That's what I'm talking about.
I'm loaded.
Locked and loaded. Like that. Oh, thank you. Yeah, your tests, you'll get them back next time. I hope you enjoyed it though. Pretty easy if you know it.
Take a walk.
Goes tutors. Okay.
Please sketch the following functions.
Oh, we're doing.
It's just a quick warm up.
Do you ever wish you could?
Like condoms.
Oh, we can do it. Is that a parabola?
How many units are there?
No, parabola would be X squared. Wait, parabola would be like X squared.
I'm assuming it's one.
It's like a half parabola.
I'd say it's a.
Oh.
Alright, are you gonna grab?
Oh, wait, I remember that. I see it.
Are you remember?
Wait. What's your license? No, you didn't.
Actually.
You actually didn't. I love this.
I'm scared why.
No, but I know he has really cool nowadays.
Yeah, right.
It's really nice. I want to know the story of this. We know how to do it. Wait, did you have Mr. Reeves?
I had Mr. Reed.
Oh, I had Mr. Reeves too. Yeah, he got.
Wait, he's not that. What? When you know.
I don't know. I really explain. What do you do? Explain it.
For what?
Negative. This means that
I started with the regular.
inside, you flip over the.
Let's think. All you can say.
I was because all you would do is talk
Flip it
about
over the.
X.
And then you stretch it by 2.
Yep.
So if it's flipped over to X. I heard about it.
We need to know.
I don't know. I don't know anything. It's like that.
Whatever you think is necessary. It's a warm up, so.
No, I agree.
That's
You're at the middle school.
What about number 2?
Hard one.
Oh, it's just
The Y
oh,
intercept
top
the
three. Okay.
zero stuff.
Wait,
The Y intercept the zero.
It's just a vertical.
No.
There's no way.
Oh my god, that's the answer.
Answer.
Oh.
Like a hat.
Oh, you did this.
That's what I said that first.
No.
Okay, wait, hold on. Wait, 3. Absolutely. Wait, is it?
Wait.
Oh my
Vertical
god.
stretch.
You. God.
No, vertical stretch.
Multiply by the whole thing. And it's a
Is
Are we about done?
is it-
I didn't so. How could you possibly get a negative number?
How it is your third one.
How would you get a negative number with the alpha?
Because it's like.
Yeah.
Wait, no, you need to pull out the headings. He said they would make the negatives. Then go, no, you have to think over.
Oh, it's still having a wire.
Wow.
Because if you plug in -1.
Yeah, no,
I'm not.
yeah, no, wait, Simmer, they're correct. You can't have this end up being negative. That would be horrible.
That'd be an imagine.
Okay, folks, so on the whiteboard in front of you, take your marker finger and just show me what the square root of x looks like. So starting at the
Zero.
origin, going this way, is that right? How many points did you actually plot?
1.
0 points. The 1 point, is that enough, you think? Does that
No.
kind of nail this in? How many would be good?
3.
I think 3 points would be pretty reasonable. So 0, 0, did that one. Also 1, 1, and then what, 2 root 2, is that the other one? 4, 2 is probably a good one to plug in, or to use, excuse me. I think this is 9, 3 would also be on this curve. This curve is called a what? Half parabola, exactly, opening to the right. It is a parabola. You can see the other half in your mind's eye, can't you? But it's not part of school. For number 2, would you please kind of show me what happens to this? Nice. So it looks like you're making a taller graph, is that right? So it's being stretched vertically. So we still have 0, 0, but 1 becomes 1 comma 3, right? So the y values are all stretched. So 4 comma 2 becomes 4 comma 6. Yeah, so something like this. Not exactly the scale. I'm just doing enough to get a good idea of what's happening here. Now, would you please show me what that negative did to your graph? Show me in gestures. What did that do to your graph? Yeah, it changed it to go over the, well, it moved over the y-axis, didn't it? Okay, and then that 2. Stretch or compress?
Horizontal.
It's a vertical.
Compression cycle 2 or 1.
Let's see.
Vertical.
1 and 4 kind of nice numbers to plug into the other one. 0 is not. Is 1 a nice number to plug in here? Instead of 1, the equivalent number would be -1/2, wouldn't it? So kind of crunching what we have. So -1/2, that's going to give us our same 1 value. And instead of plugging in a 4, I think we're just going to plug in that 2, right? We're plugging half of that, -2 specifically. Thank you. To give us that 4. So you get something that looks like this, resulting in reflection over the y-axis. Are we comfortable with this? Because this is what we're doing. I think it's going to be a review largely for most of you, or maybe just kind of a cleanup time for many of you. We're going to be talking about transformations of functions, as you saw, as the very first topic on today's lesson. Right, transformations of functions. Yay. So let's get to it. Take a look at these, make sure they align with what you already know. Look at all 4 boxes, check the vocabulary, the graphs, check the functions. Louis Armstrong. Does anyone know Louis Armstrong?
Yes, he played the trombone.
And he sang like that.
Yes.
You play trombone? Trumpet.
I played trumpet.
Mm.
You and Dad?
Yeah.
Anyway, All right, is the analysis here going okay? So some new words, so maybe some new words. Notice that these are the first two are called translations. Have you discussed that before? So translation is another word for shift or move, yeah, or slide maybe. Translation is directional. So if the translation is positive, that means it's going to be, well, if it's vertical and positive, that means it's going up. If it's vertical and negative, it's going down. So like if I say vertical translation by -3, that means down. And horizontal translation, see, right? That makes sense here. Are we okay with that? X plus H is actually a translation of opposite of H units. Right, whatever happens inside the parentheses is opposite of what you would imagine. Here, new word. Dilation, have you discussed this? Dilation is just all-encompassing, both stretches and compressions. So it's a stretch if that A is greater than, it's a stretch if it's greater than 1. If we're talking positive numbers, and it's a compression if A is yeah, between 0 and 1. And then of course, we're talking about absolute value of A there. Yeah, so vertical dilation would be either a stretch or a compression. Same thing with the horizontal. And are we okay with this 1 over B? Like that, the number 3 in the warm-up, that was a vertical, sorry, that was a horizontal compression or horizontal dilation of by a factor of 1/2. By a factor of 1/2. They should not be units by a factor of just that number. The shifts or the translations are units. And when you multiply by a factor, that's just by a number. Okay. This negative on the outside results in a reflection over the x-axis, as you can see there. And like the one that we did earlier, the negatives on the inside, and it's a reflection over the y-axis. Okay. With your neighbor, discuss example 1.
Transformation of that's that G of X. Okay, so the thing and stretch by
Stretch by 2. Wait, no, but you have to specify the stretch. So stretch 3 to the vertical. What's outside of
Yeah.
this is outside of the item. So it's a final whole.
vertical stretch of 2, and if it's less than 1.
So if it, yeah, then if it's less than 0, sorry, wait. Yeah, if it's less than 1, like a fraction,
Then it's a vertical.
then it's gonna revert you less.
Yeah, wait, but I'm.
And if it's negative, then it'll flip over there.
Yeah, right. Wait, inside the bracket?
About 10 more seconds.
Flip. Then it's like, then if it's larger than
Fraction,
1,
then it's gonna be a stretch.
it's a fraction of the stretch. Then anything else will be validation.
See, I'm low. Let's have Dr. Beatty.
Okay, so I want to hear what you talked about. Haley, can you tell us what we did for example 1, please?
Goes up by 1.
Right, 3, stretch 2. Stretch by a factor of 2. Are we good? Okay, and of course, when you say up 1 with our new terminology, that would be vertical translation by 1 unit, horizontal translation by 3 units, and then the last one would be what kind of dilation? Vertical dilation by a factor of 2. What order do we have to put these in? Like, if you were to graph this, what would you check in with your neighbor? What does the order have to be?
It goes to left to right.
It goes inside, huh?
Oh. Yep.
Multiplying.
So move over first and stretch back. I know.
I think so.
Make sure you type.
So inside.
Which two first?
Are you there?
Okay. Haley, I feel like I didn't write down your whole answer. What kind of stretch was it? Was it vertical or horizontal? Vertical stretch. I think you said that, but I forgot to write it. Thank you for your answer, by the way. Who'd like to summarize what order we should be doing these in? Yeah, Jonas? Are we good with that? So, yeah, it has to do with PEMDAS,
Oh.
except parentheses and exponents, those define what's inside the function, also defines the function, so we're going to ignore those. So just the MDAS, which is problematic. What is problematic with this MDS, MDAS? What's problematic with saying M, then D, then A, then S? Do you know? Is multiplication always before division?
No, it's left to right.
It's left to right. So they're kind of the same priority. So this is whatever's multiplication to division comes first, whatever addition is subtraction comes second. So which is why in this case, when you're graphing the function, the first thing you would do is stretch it vertically by 2 and then move it up 1 is over right, or to 3 to the right and up 1. Are we good with that? Yes.
So the 1 and 3 don't really matter, or when.
The order doesn't matter. Yeah, does not matter. Because you go up 1 and over 3, or over 3 and up 1, arrive at the same place. The problem is if you go up 1 and then stretch vertically, you're stretching the vertical translation. So that's why the stretch has to come first. Yes.
So it's, you do the, like the vertical part first and then it doesn't matter?
You do the stretch first. And then either horizontal or vertical translation.
Oh, okay.
So it's first, anything that's multiplication or division comes first, anything that's addition or subtraction comes second. Yeah, I'll give you some time for example 2. I think you can do it. You may want to discuss before you graph anything. Oh yeah, this number 2 doesn't go with the graph.
Yeah, so there's a flip over the x-axis in a vertical stretch of waiver, and then there's also a horizontal.
Yeah, so basically, yeah, you're just gonna.
Wait, so we're writing out like that?
Vertical stretch, right? Oh, no, it's actually.
Do we flip?
Horizontal.
And that's the condition.
Yeah. Wait, we gotta go left to right.
Yeah.
Do that right?
What?
No. Does it matter when you flip over? Wait,
Land on your head.
First we do
Okay, wait, so
-4.
Are we ready?
I think you could do them in the same. Like, yeah. let's do it.
Or do you want to do it?
Yeah, the formatting's so strange here. It looks like this graph goes with example 2, but it does not. Okay, are we ready? Nia, can you help us out? What happens with this? Okay, so there's a reflection. Oops, that should be an L. Reflection over x-axis, you said? Okay. And you said dilated by a factor of 4? So I'll say VD times 4. Okay. Are we good? Thank you. Does it matter which order we do these in? It does not matter, actually. It'll all end up in the same place, as long as it's not interrupting addition or subtraction. Okay, this one, I think you could do this. Go for it.
Okay, then now we just go left to right. So this is we move this to the left.
So you're doing the upper graph.
And
Yeah,
then,
left three and down.
There's apple for you, upper graph.
Oh, you have to go.
talk to him, Jimmy.
You get this.
Did you finish?
Yeah,
Yes.
like basically what
Those are so low.
there's a thing of fuel, right?
Look. 1, 2, 3, 1, 2, 3.
Oh, my. God. Yeah,
Yes.
no, I was checking.
Okay, so from everybody,
Like this kind of work, like 2 more out. We got it.
there we go. Okay, so there's a number right there. You see me pointing to it. Which direction is going to move the function? You know, it moves it to the left, and then this moves it down. So 3 is to the left and down 4 units. How many points should I focus on to move? All of them seems a little overwhelming. So the minimum number of points. So 4. Do you all kind of focus on this one, this one, this one, and this one? You move those left 3 and down 4, or should I move it down 4 and left 3? Doesn't matter at all. Did I do that right? Like this? And now we'll get all infinite number of points. This is, do you know how high that is in between that -3 and the 0? Is it 1.5? It is a semicircle, so that is the radius, 1.5. And then something like this. Yay. Okay. I give you a moment to work on this one, example 4. If you have questions, check in with your neighbor. If you still don't understand, let me know.
Yeah, exactly. No. Yeah. But where the x-axis, okay, now it's important.
Wait, what is negative relation?
It's just -1. It's just -1. Because h of x, it's h of x. What's up?
It's the horizontal compression of.
Yeah.
Why is it horrible?
Flip over that. Okay, but now you have.
You literally just explain the rule to me. Yeah. Which one are you on?
This one is example 4.
Wait, why is it horizontal? Oh, horizontal compression too.
Yeah, yeah.
So we multiply by
compression.
1/2.
Yeah, exactly. So I was confused, but you said 4. Okay, wait, so we have to flip it over the x-axis.
Okay, wait, we got this. Flip over x, so it's gonna go to x to 3.
That's all tomorrow.
How about?
I stole this from you. I did. Wait, tomorrow.
How about?
It's not for me, it's for my good friend. I can't even read it on the like.
It's all right, don't worry, I'll just,
Go
I
through
got it.
Okay, wait, we got this.
Make sure you and your neighbor are on the right track.
3,
3,
and then divided by 1/2.
What about?
No, times 1/2, so 1.5.
for the horizontal.
Yeah.
Just back to
Divide by 2. Divide by 2, 1.5, right? Yeah, okay, we got that.
Wait, why would it be 1.5 if you're at 4?
3 times 1.5.
You're at 4.
Oh my god, I'm so slow. No, it's fractional reason.
That point's at 4. Oh, -2. Wait, it's -4, right? But this is a horizontal stretch. Yeah, I know, but this is horizontal stretch, so why would you, this only.
And then
affects-
we flip it, right?
Yeah,
To
flip it.
3.
Yeah, to 3 there.
My gosh. 3, and then times 1/2.
Yeah, but that affects the horizontal stretch.
3 times 1.
No, but like, no, but why would it, okay, yeah, no, I understand, but this, doesn't this affect this affect horizontal movement? Yeah, like compresses horizontal.
Are you about ready?
How it works?
Am I slow?
And then it goes up. I think I'm like 95.
Wait, let me, wait. I'm 5% sure you're.
Wait, okay, look, but this is inside the equation, right? So that means it's a horizontal compression.
Meaning it's getting smaller.
Yeah, so it goes from 4 to 2.
Oh, I heard it.
Yeah.
Well, down.
You want a vertical compression because you're saying it 3 and then 1, right? Wait, can you just double check with me though? Is this horizontal compression?
Basically, all the axes are one.
Like you just multiply the x value by 1 half.
Are we ready?
Is Megan gonna do one? Yes.
I'm ready.
I believe you.
Okay, so can you just show me what's going on with this function with gestures? Like when I point to this, what's going to happen? Thank you for pointing upwards. Of course, that is a unit of 1. This 2 right here. Show me. Show me. It's a horizontal compression, right? Or dilation by a factor of
2.
horizontal dilation by a factor of 1/2. Exactly. And that negative, what does that do? Can you show me? Show me. Takes those y values and bring them down or down and up, right? So it flips over the x-axis. Okay. And how many points would be the minimum I need to graph in order to get a good graph here?
5.
5.
Oh, yeah.
Let's see. We have definitely this one, right? Definitely that one.
Graph the whole.
1, 2, 3, 4,
I said 6.
5. Do you need to do the whole 2?
Graph the whole.
We should probably do the whole 2, shouldn't we? And then when we plot that, of course, it's going to be a whole.
Not like your one.
What's that? Did I do something wrong?
Oh, that's like with the bolt.
Okay. Yeah, I just approximated here. Okay. So I need some help. Just moving these one at a time. I'll call this 1, 2. I'm just going from left to right. 3. Uh-oh. My left to right just failed. 5 and 6. Okay. So help me move these, please, Connor. Which one do you want to move first? Okay. Let's do it. -4, 3. And how did you get it there? Oh, -4, 3. Like this, -4, 3. Okay, this is good. So you shifted over the x-axis. Are we good with that, everybody? If we would have done the horizontal dilation first, would that have been different? Exactly the same thing. Horizontal, not the compression or dilation, excuse me. You want to keep going? Thanks, Connor. Which one do you want to do next? I think that's a good idea.
That one you can put down 2, then it's flipped again, and then you can move it over to the right by 1, and then you can move it up 1.
Okay. You're doing great. Keep on going.
1, flip it over to 0, 2, and then it doesn't get like by the 2x, and then you just move it up to 0.
Okay, I'm going to call someone else. You've had enough fun here. Well, thank you. And Nathan, can you help us with the remaining points?
Which ones?
4, 5, and 6.
So first you have to flip it over the X,
Which one are you doing?
or I guess.
Okay.
Plus 4.
Oh, that's 4.
So you flip it over the X, so it would be at 4, -2,
Okay.
and you can do the horizontal dilation by 1/2, so it'd be at 2, -2, and then just add 1, so it'd be at 2, -1.
Put an open circle there.
And what's the red point?
Oh, this is 5 and the other one is 6.
What is that? Point? That's just like that, the dot. That's
Yeah, they just had a random point there.
oh, okay. Yeah, so you flip it over, so it'd be at 4, 1, then it'll be at 2, 1. So it'll be at 2, 2.
Okay,
The last one is going to be 6, -4, and then 3, -4, so 3, -3.
like that. Okay, thank you. So I think these will go together like this. Did I do that right? And then this one lines up pretty nicely, doesn't it? Is that it? Oh, I have to make sure that's put there. Are we good?
No.
Yeah.
A hole is just still like, even if you move it, it's still like the point.
Right. Yeah, we still have to move that hole. And does this function even pass the vertical line test?
Not because of
The original function, does it pass the vertical line test?
Yes, the vertical line.
It does, doesn't it?
Not horizontal.
Definitely not the horizontal, which means it is not 1-to-1, which means it can't be inverted. It's not invertible.
It is a function. Passing.
It is a function. Passes a vertical line test. Good. Okay, so we did finish that one. Oh, really quickly here. Back to example 2. For n of -6. How do you get that without the graph? N of -6. How do you get that without looking at the graph? Can you just plug it in? Does that work? N of -6 equals -4 times m of -12. Is that right?
You didn't find out next though.
Oh, we didn't see. I'm sorry. We shouldn't be doing that. We should be doing one that we could see. Excuse me. I meant to do a g of -6. Sorry, down here. G of -6. Can we just plug it in? F of -6 plus 3 minus 4. Does that work? Let's see. That gives us f of -3 minus 4. And f of -3 we know is 3. 3 minus 4 equals -1. But we already had that on our graph, didn't we? Yeah, Haley?
Should the graph like a little semicircle be the other way?
Like down?
Yeah, isn't it reflected over here?
For this one? I don't think there's a It's just translate.
Oh, sorry, I'm looking.
Yeah, it's weird to have the graph below the problem. It's so weird. I think that it's really poor formatting personally. I'm gonna recommend we change it for next time. Okay, same thing here. I'm like, okay, now I have to do example 4, but it's done. Ah, this is interesting. Let's see what you got for example 5 and 6. Everyone's okay.
Me, sorry.
No, it was like.
Shut up.
I know, right?
Oh, it's the back stick.
Wait, what?
Oh my God.
You're doing examples 5 and 6.
Augie. Happen to the domain of F.
Like,
Find the domain. Wait, what? Do we just leave all of the values? Yeah, right?
Yeah, okay, so.
We just move all the values.
Okay, wait, yeah, no, all we need to find is like find. Wait, so find these points, so find these points, and then these individual points, and then apply the
Oh, it's
transformation.
the graph of the last.
No, it's a different, Okay, wait. Wait, no, we can just apply the transformations.
That's what.
-3, but
So each value, ready? Move the x value to the left, so it's gonna be, oh, it's easy, look, it's just the domain is this minus 3, -5.
That's the thing. When did
yeah,
you
you can
take
still
it?
apply, you can still apply the transformations. That's a shift over the x axis.
Oh,
Okay, and then 1.
Okay, so then.
The one value.
This is for, this is, like, it's almost like this. Okay, so like, this is a shift to the left, so this is negative 6.
Horizontal. C would be.
Okay. And then this one, you flip it, so this is -1, because that goes to -1.
Oh, this is the table.
Okay, and then.
Negative
It's
2.
not, it's
The
not.
table goes with, no, example 6.
What? Okay. Negative, so then,
Oh, it's negative.
They did it again. I can do that.
Brian.
Yeah, it
I
is.
bet. Son, how did you get?
oh, because you just apply the translation again there, I'm like 95%. Okay, wait, let me show you example. Give me, look, so you have this, and now you have the negative 3 point, okay? And then you apply the thing in your left, 3.
So that's like.
Okay, and then that's your new domain. That's literally applied to the left 3 here. Okay, let's do number 6.
Yeah, so it's like.
Range.
Oh, we should call it.
Okay. Above. You see?
Wait, do you guys?
So what'd you make for?
Oh, we got it. We just plug it in.
Yeah, when x is equal to -1.
Then it's just. Then what's here?
Yeah.
No, you can't do that. You just have to solve it. Okay, so 3c times. Okay, this is -1.
Wait, how do you find the?
Okay. Yeah, okay, so then when p of x is. What x? Oh, shit.
Wait, just. I want to find it. Oh. To pull out. Look. Wait, that doesn't.
Okay, folks, seems like you're just about done. Are you ready? Okay, for example 5, what I like to do is for us to imagine our function in front of us. Do we know what the function looks like? There's some idea. We know the domain is from -3 to 5, and I don't like this notation. Instead of this, let's use what kind of notation? Let's use interval, don't you think? -3, 5. Are we okay with that? Being the same thing. Okay, so let's grab a hold of that -3 to 5 just in front of you. What would that look like? Probably -3 over here and 5 over here. Does that make sense? Like there's your domain. And then what do we do with this domain for this new function? We're moving it 3 to the left. So instead of from -3 to 5, it's going to be from -6 to -6 to 2. Are we okay with that? Okay. For the range, we start with 1 to 3. Could you show me what that 1 to 3 looks like in front of you? And these are y values, so like one hand below the other one is from 1 to 3. And then that first thing that's going to happen to that is 1 to 3 is going to be, it's going to double. So it's going to go from
9.
2 to 6 and then -1. So
It's 4.
-4 is that -4? That's right. So I guess in my thought bubble, we're saying from 1 to 3, we doubled it. So it went to 2 to 6 and then -4 like this, -2 to 2. Is that right? Is that what the domain ends up being? I think this is exactly the same as example 3. Is it this? I think it's exactly the same. Like the domain is -3 to 5. Oh, except you're right. It didn't have a stretch. It didn't have a stretch. Okay. That's interesting. They use the same domain. Okay. Any questions? Okay, for this one, we're able to do h of -1. Can you show me your answer? Can you show me your answer for h of -1? Yeah, for example 6.
Wait, it's.
Oh, do you need some time?
Yes, please.
Let's give him 30 seconds.
Okay, it's
Alright, you're ready.
P, but P
Yeah.
of,
Plug in.
what's your
You're
time?
saying. So -2.
Perfect, so then
There's 3.
P of
Negative
Yeah, I went, so you.
-2 is one.
Zero. Oh, it's negative.
One minus one.
Oh, negative.
What?
Negative 2.
So-
Wait, no, you have to-
Equals two.
This
Two.
one. So
I believe.
Okay, this one.
Two.
What's your density? 4? Here, this is 3. So 3 times 3 minus 1.
Damn, you're actually smart.
Yeah.
I heard those.
Yes.
That one.
P of 0 is what? Negative.
Oh, yeah, he said it's gonna be like the.
So 3 times negative 1.
Oh, you should.
Negative 4. Here, we're done. It's on.
Three times negative.
Are we ready?
Yeah, negative 4 times 5. It's like you said 3 times negative 1.
That
Okay.
is-
Then that's what it is.
Okay.
It's so hard.
I like this.
Let's start with A. I'm gonna ask Elle to help us out with this. Do you have any idea how to do this? Okay.
-1 in HVAC. You get,
Yeah,
-2 minus 1.
like this. Okay.
Or minus -1.
Oh, minus one. Okay.
P of -2 is, and you find 1. And then you get.
Are we good with that? Oh, perfect. Thank you very much. H of 2, please show me what you got. So I'm seeing 8s everywhere. Is that right? Is it 8? Or 11? Uh-oh. Is it 8? I know, let's see. H. I'm just gonna follow L's method. You just plug into 2. 3 times P of 4, is that right? Minus 1? And P of 4
Last one?
I actually got.
is 3. Then 8.
Oh, wait.
And for,
Oh, yeah.
there you go. And for C, the answer that you get is
Oh, wait, that's there's one.
nice. You have negatives
That's-
pointing downwards, negative.
Easy for that thing.
Are we good with that? Okay. Very straightforward. Okay. Example 7 and 8. And I think you do all of these. Well, let's do 7 and 8, then we'll do 9 together.
So. Makes you happy.
It's just my brain.
Oh, wait, yeah.
Let's go number 8. Buddy, time to do number. Oh, wait, Mr. Lieber, you want us to skip them or something?
No, we're doing examples 7 and 8.
7 and 8, okay, so.
You ready? Function G. Horizontal dilation, that's
I
when
got
it's
the
both,
other
right? So
one
it's
for
stress.
it, like.
No, so it's inside the
So,
pencil.
okay, the horizontal dilation by a factor of. Wait, no, it's 1/3 for, right? Because to get out.
By a factor of 3. No, it's 3x.
Get 4 at.
That'd be a factor of 1.
Sure.
Mr. Lee, because by a factor of 3, I'm gonna use 3x.
That's a tough one.
Like, I think it'd be 1/3.
You have your notes? You have a.
Well, because it says, okay, has a, f is a horizontal dilation by a factor of 1/b units, which means 1/b unit, which means b would have to equal 1/3. Yes, I'm positive.
It's definitely 1/3.
I think it's 3.
No, it's 1/3, it's 1/3. Because we're. They use the off factor. I thought we were just doing no means at all.
Yeah, but it's 3.
Yeah, shit, I think it's stretched out as 2.
You were supposed
Yeah,
to do
okay.
2.
Structure of question, you say
I
it,
think it's 1/3.
you're changing by a factor of 3.
I said 1/3.
Oh, so the 1/2 of the. Please say something that.
Unvalued pay.
Okay, I agree with you on.
It's all the part.
For the first time.
No one's safe. I think right. And it's
Did you finish?
Did you? I did not.
Last one, I knew when I got.
Can you tell me what the sentence about?
I'm sure.
Wow.
Wow.
Are we done?
Negative.
Do you need more time?
I got it.
I know you guys. You're Max.
Ha.
And Max.
Yeah, that's what I'm saying. We should have that. I think it's negative 3.
I'm gonna be a fan.
I'm OJ.
Yeah, he's not on TikTok.
Okay, folks. It's developed a Halloween costume, so we are on to example 7. I just want to know what A, B, and C are. So Simran, A, what do you think?
I actually do not know which one.
No?
Wait.
Did you do anything for example 7?
Wait, no, okay, like 8.
Oh, wait, I want to hear from Simran.
You think it's 1/3 X or 3X?
Okay, well, let's do one at a time. Because there's an A on the outside, there's a B on the inside, and C is right there. So were you sure about any of them?
I was sure that the outside would be 4F.
Or F? I think just a 4. 4 times F. Yeah. And any others?
And then I think it's 3X in the inside.
Okay, so B if so we have G of X. I should write this down in context. 4 times F of 3X and then
Minus
-7. So,
for that.
so you're sure that C is -7. Okay. Are we good with this?
Sorry, I don't understand.
Somehow Siri got it called. That Nia? 1/3? Okay. Why do you think that?
It says F of BX, it's a horizontal dilation by the factor of 1/b. So if it said that it's a horizontal dilation by a factor of 3, if you put it in the format, 1/b.
Nice. And thank you for referring back to the actual notes for this. Nice. Right. If this were the function, then this would be a horizontal dilation by a factor of 1/3. So we do have to adjust that to be 1/3 here so that this is now a dilation by a factor of 3. Which I think you're just kind of going back and forth. Which one is it? Which one is it? Are we good with this? Thank you for your help. And for example, 8, we're again looking for not only A, B, and C, but also for a value of K of -6. So for this one, I need some help from the one and only Shiv.
Yep.
You knew it, didn't you?
I didn't leave it all. Okay, so we got a vertical dilation of 3, so I'm gonna say A is equal to 3.
Okay. So K of X, you're saying this is 3.
Say that B is equal to 2.
Okay. And
I'm
then
gonna say C is equal to 1, so +1.
Simran, what do you think about this?
I agree.
You sure?
Yeah.
Okay.
Then that we're gonna say -6 times 2, which is -12.
-6. Okay. So 3 times H of -12.
See that when you plug in what's called -12 in the function, we get 1. So 3 plus 1 is 4. Okay.
Yeah. You can't forget anything you learned, right? Even kindergarten stuff. Is he correct?
Yes.
I would say.
Yeah.
Nicely done. Thank you. And lastly, the function P is given by this. P of X is equal to 3X minus 2. The graph of R is an image of the graph of P after horizontal translation 4 to the graph of P. If R equals that, find the values of A and B. I'll give you a moment to finish that up.
So
It doesn't say.
3X.
It says 4 plus 2. Sure, I got it. Don't worry, you sure?
Oh, translation. Three X minus.
I think everybody should be like.
So what is it? Others
What's your favorite color?
What do you think?
Green. Blue? Pink? Purple?
You used to say that.
No, I literally,
Oh,
especially violet.
I'm a big like,
That's my thing.
like, I don't know, I don't know,
Ultraviolet.
like real purple or whatever it's called.
Is your favorite color purple?
One of them.
Julie, what's your all-time favorite?
Purple's one of them.
I like red.
This is not a dilation.
Okay, did you get it? How are we supposed to do this one? Max, you have an idea?
Yes, I do.
Okay,
Because this is a horizontal translation and we're given a +4,
okay,
we're adding a 4 to the end of P of X.
okay.
P of X equals 3x minus 2 plus 4. Which simplifies to
No.
3x plus 2.
Horizontal translation.
Wait, oh, wait, that.
So you misread it. So this would have been correct. This is the correct answer to a different problem. Okay, so that would have been if it said a vertical translation. The plot thickens.
Okay.
Okay, Nathan?
Yeah, basically just like, since, the horizontal translation of 4, you just put like 3 in parentheses, like x minus 4 and minus 2. Yeah.
Wait, is it -4 because it's? Oh.
Is it 4 to the right? How do you know it's 4 to the right?
Translation.
It says horizontal translation. It's positive, so it's definitely to the right. So then we work this out. 3x minus. Whoa. Whoa. Come back. Minus 14, is that right?